Okay, so now we want to talk about combined. I was going to combine those words, combined and joint variation. They're slightly different things. So if you have joint variation, it really means that it's varying in the same way with two different things. And then combined variation means that maybe it's directly with one and inversely as another. So when you see, like in this example, P varies directly as Q and R, if you take that apart English-wise, it means P varies directly as Q and P varies directly as R. That means that it's joint. It's varying jointly with the two of them because it's just directly. So let me get my pen. Hello. There we go. So, there we go. P varies directly as, so P equals K times Q and R, so Q, R. You just stick them all together like that. P equals 60, so 60 equals, when Q is 4 and R is 5, so K is what is left out here. Q is 4, R is 5. Let's go ahead and simplify that to 20K. So I've multiplied by 20, and it wouldn't have mattered if you wrote 20 on the right. That's just non-standard, but we're going to get rid of it anyway. So we want to get rid of the 20, so we need to divide. So 3 is K. And now we want to find P when Q is 8 and R is 2. P equals 3 times Q times R. So P equals 3 times 8 times 2 equals 48. So P is 48. Now this one, instead of saying varies directly as something and something, or inversely as something and something, it's directly as one thing and inversely as another thing. So that is combined. But it's still the same basic situation. You've got the 1K, the K is always on top, or just to the side if there is no bottom, but K is never in a denominator. So Y varies directly as X and inversely as Z. So we only have the 1K, but directly as X, so it's next to the K, inversely as Z, so it's under the K. Y is 22 when X is 4 and Z is 6. So plug in 4, plug in 6. We want to get rid of the 6. So we have 6 times 22 equals 4K, because only the 6's are canceled so far. We want to get rid of the 4, so divide by 4, so let's see, 33 is K. And we want to know Y when X is 10 and Z is 25. So what is Y when X is 10? So 33 times 10, and Z is 25. So that's 330 divided by 25, which is 66 fifths, which is a fine upstanding answer, or 13 and 1/5, so 13.2. So this time we have two things going on. It varies jointly as B and C, but also inversely as D. So A varies, so A equals, jointly as B and C, K, B, C, and inversely as D. So jointly as B and C means B and C are on the top, inversely as D means D on the bottom, but again, just the 1K. So A is 20, when B, C, and D are given. So let's go ahead and write K. B is 5, C is 2, D is 3. So we have 10 over 3. And you can do the same process as before where you multiply by 3 and divide by 10. Or you can say, let's just multiply by the reciprocal of 10/3. So 20 times 3 over 10, I can cross those out and get 2. Or you can just do 60 over 10. And either way, you're going to get 6. So 6 is K. So we want to find A. So A equals 6 times B, 12, times C, 9, divided by D, also 9. So these two actually just cancel out, and we get 72. The amount of money a learner makes in the summer, so we can put D for dollars, varies jointly as the number of hours they work per week, so we can say H, and the number of weeks they work, let's say W. So D equals K times H times W. A learner makes $765 when they work 10 hours per week for 9 weeks. So 765 equals K times 10 times 9 equals K times 90. We want to unmultiply by 90. So divide by 90. 765 divided by 90. So 8.5. So D equals 8.5 HW. How much money would they have made if they'd worked 13 hours a week, so that's more hours per week, for 8 weeks, so that's fewer weeks? So D equals 8.5 times 13 times 8. Oh my goodness, losing my pen. So 8.5 times 8 is 68. So 68 times 13. So they would have made $884. Still don't know why I'm getting all these jagged lines here. Interesting. So what was the 8.5 in this case? The 8.5 was their hourly wage. You take the number of hours per week times the number of weeks you work, and that's the total number of hours you worked. So the hourly wage in this case was $8.50. The volume of gas varies directly as the temperature and inversely as the pressure. So this is a joint variation. So volume, we'll say, temperature, and pressure. So volume of a gas varies directly as the temperature and inversely as the pressure. If the volume is 230 cubic centimeters, when the temperature is 300 degrees Kelvin, and the pressure is 20 pounds per square centimeter. So that's the first part of the question, and then we'll get to the end. This is how we solve for K. So this is 300 divided by 20 is 15. K. So we need to divide by 15. So we get, let's just do 46 thirds. That's just dividing by 5 on top and bottom. So 46 thirds is K. And then what is the volume when the temperature is 270 and the pressure is 30? So volume equals 46 thirds times the temperature divided by the pressure. So 270 divided by 3 is 90. So we can clean that up right away. 90 over 30 is 3. So we really have 3 times 46. So that's 138. And the question was, what is the volume? And volume was given in cubic centimeters. So it should still be in cubic centimeters because all the other units matched. Now, this one is one that I kind of promised you. You don't have to just say y varies directly or inversely or jointly or in any way with x. It could be with x squared or x to the fifth or the square root of x or the cube root of x or 1 over x or really any function of x. But if everything works the same way, and you don't say x squared, you say the square of x, and you don't say x to the fifth, you say the fifth power of x. That's just sort of a convention though. So the centrifugal force of an object moving in a circle varies jointly with the radius of the circular path and the mass of the object, and inversely as the square of the time it takes to move about one full circle. So centrifugal force we can label C, radius R, mass M, and time T. Those are sort of standard. So the centrifugal force varies jointly with, so equals K times the radius and the mass, and inversely as the square of the time, so T squared. A 6-gram object, so mass equals 6, moving in a circle with a radius of 75 centimeters, so R is 75, at a rate of 1 revolution every 3 seconds. Now remember on time, the time was the time it takes to move about one full circle, and this is 1 revolution for 3 seconds, so T is just 3, has a centrifugal force of 500. So C equals, 5,000. Find the centrifugal force of a 14-gram object moving in a circle with a radius 125 centimeters at a rate of 1 revolution every 2 seconds. Let's put this one on hold a second. So the first part said 5,000 equals K times 75 times 6 over 3 squared. 5,000 equals K times, now 6 over 9 is 2 over 3, so we get 150 over 3, but that's 50. So dividing by 50, we get 1,000 is K. Okay, so, oh gosh, I'm sorry, 100. I'm so distracted by these weird little angular things that my pen's doing. I think I need to adjust my settings. Anyway, 100 equals K. So now the question is, what is the centrifugal force? So C equals of a 14-gram object, and we know this is 100, times radius, which is 125, times mass, which is 14, divided by time squared, and this does 1 revolution every 2 seconds, so that's 2 squared. So this is 100 over 4 is 25. 25 times 14. Gosh, I don't even necessarily want to do this without a calculator. That's okay though. So 25 times 125 times 14. Again, the 25 is 100 over 4. So 25 over 14 times 14 is 350. So that times 125. Okay, if I haven't mismultiplied, then it's 43,750. So again, there was more to plug in. The numbers were kind of bigger and maybe more of a beating to deal with, and you had 2 things on top and something squared on the bottom, but it was just the same process. Once you started going, everything's the same. So it may look scarier, but it's really the same thing. And I believe that is the end. Yes. So I will get these posted tonight and get you guys invited tonight and get you some practice things to work and also some assessments. The quizzes will be timed, and you can take them twice automatically. If you want to take them again, you just need to show me a video of you doing some of the problems from the practice and explaining as you go so that I can see that you are ready, and then I'll open it back. And if you just need slightly more time, let me know.